Take two.
Hello, annyeong. I'm Chai. She is Tu. We are going to introduce our members first. Go, Yo, Chen, Lu, Shafika, Haliza, Uy, King, Sasha. Let's start watching our video. See you.
Today, we would like to discuss about what is sampling distribution of mean. Sampling distribution is a probability distribution of a given statistic based on a large number of samples withdrawn for a specific population given that. That is a fixed sample size. It's used to estimate the characteristics of the population by using the characteristics of the sample. There are two types of sampling distribution, but one of the important sampling distribution which is sample mean. Sample mean is known as an unbiased point estimate of the population mean because there is no systematic tendency to overestimate and underestimate the population mean. Be able to measure the infinite in population if the observation is normally distributed. Now, you have an idea about the concept of sampling distribution of a statistic. Next, let's proceed to explain what is the sampling distribution of mean.
Sampling distributions of mean is a probability distributions of means for all possible random samples with a given size from the population. It is used to determine the average of the population from where the items are sampled, and is typically represented in the form of a table, probability histogram, or formula. The distributions of the sample means tends to be a normal distribution, which is bell curve through central limit theorem if the sample size is big enough. This theory explains that all the mean of each possible outcome are laid under the bell curve. In other words, sample means equal to population mean. The sampling distributions of mean consists of mean and standard deviation, and we will discuss in more detail about this in the next.
So we are going to discuss about the properties of sampling distribution of means. The first one is mean. The mean of the sampling distribution of mean is equal to the means of the population from which we have sampled. Therefore, if a population has a means, then the means of the sampling distribution of the means is also called as mu. The symbol mu x bar is referred to the means of the sampling distribution of the mean. The formula can be written as below. Okay, the second one is variance. The variance of the sampling distribution is equal to the variance of the population divided by the sample size. When the larger the sample size, the smaller the variance of sampling distribution of mean. Hence that the variance of the sample means is n times smaller than the population variance. The variance of the sampling distribution of the means is computed as follows.
Next, standard deviation. The standard deviation of the sample mean is equal to the population standard deviation divided by the square root of sample size n. It also is called as the standard error of the mean. The spread of the sampling distribution of the mean decreases as the sample size increases. Last but not least, random sample drawn. If a random sample is drawn from any population, the sampling distribution of sample size, the more closely the sampling distribution of mean will resemble a normal distribution.
What is central limit theorem?
A statistical theory which tells that the sampling distribution of the mean of any independent random variable will be normal or nearly normal only when we draw repeated samples from a given population until the sample size is large enough.
How to determine the sample size? First factor is requirement for accuracy. Second factor is the shape of the underlying population. What is the importance of using central limit theorems? Which are, first, to simplify the problem and measure the accuracy of the statistic. Second, to understand when performing any type of data analysis. Moving on, example what the central limit theorem is saying. The more times you roll the dice, the more likely the shape of distributions of the means tend to look like a normal distribution graph.
How many types of central limit theorem?
I'm going to find this area here first, and then I'm going to find this area, and here's the z formula we want to use, and the values. For my upper bound, the sample mean, that's x bar, is 25, minus the population mean, which was 12, all over standard deviation, given in the question as 8 pounds, divided by the square root of n in the sample, it was given as 4 dogs. So 25 minus 12 is 13, and 8 divided by 2 is 4. That gives us 3.25. And I'm going to want to look this up in the Z table. It is 49.94%. Next, I want if the equation is going to be exactly the same. 8 minus 12 all over 8 divided by the square root of 4. 8 minus 12 is negative 4. 8 divided by 2 is 4. Gives us a Z of negative 1. We can ignore the negative sign and just look up 1 in the Z table. That's because both sides of the distribution are symmetrical. And if I look up a value of 1 in the Z table, I get an area of 34.13%. So I found my two areas, 49.94% and 34.13% is 84.07%, and that is our answer. That is
I'm going to subtract mu, that is the mean given in the question, mean salary of 29,321. So we've got two margin. I'm going to divide this by standard deviation, that's given here as 2120. And I'm going to divide by the square root of n. N is the sample size, 100. This equals negative 321, and if I work this out on a calculator, I get 212, and if I divide this through, I get negative 1.51. So here's our z-score. Now we want to look this up in the z-table. The z-score of negative 1.51 gives me an area of 93.45%. Let me draw a quick normal curve to show you why. Here's my bell curve. This is a z of 0, and what we have is negative 1.51, which is somewhere over here. And what the left-hand z-table has given us is this entire area over to the right. So this area right here is 93.45%, and we're looking for the probability a salary will be less than 29,000, less than the z-score. So we actually want this tiny little tau here. So what I'm going to do is subtract 93.45% from 100%. And when I do that, I get 6.55%. That's roughly equal to a decimal of 0.07.
Well, let's take a look at a graph. We've got an order, and we're given the mean in the question as $110 a week. Standard deviation is 20, and we want to know what's the probability their benefit will be greater than 120 per week. I'm just going to take a guess at where 120 is. So what I'm interested in is this area. Their mean benefit will be greater than 120 a week. So if we find out, in order to find the area, we want to use the Z formula. You basically just minus mu, that is the population mean, and it was given in the question as 110. This is going to be all over sigma, the standard deviation. That's given here as $20. Divided by the square root of n, the sample size was 25. Well, 120 minus 110 is 10. And then we've got 20 divided by square root of 25 is 5. 10 divided by 4, 2.5. So my z-score is 2.5. So this boundary right here has a z-score of 2.5. And because this is a bell curve, I know that this half is 50%. So what I'm going to do is I'm going to look up this area in the z-table between 0 and 2.5. The area here is 49.38%. I'm going to add 50% and 49.38. That means this total area here is 99.38%. The area under a curve is 100%, so that must mean this blue area is 100% minus 99.38%. That gives us 0.62.
Replacement of size 2, that's why we have 5 and 5, 5 and 85. So how to get means 5 plus 5 divided 2, then we got 5 and so on. So here, we have 4 row because we have 4 possible numbers that's mentioned like that. Okay, the possible value of sample mean, there are 9 possible value of sample means is and so on. The value 5 happens only one way because location H5 must be selected both times, also the same thing for the number. Then the other values happen more than one way. It's more likely to observe 5 and 65. There are 60 samples more equally likely. We obtain the probability distribution of the sample mean just by thing.
So here we put the mean 5 because there are one only have 1 first, 1 over 60 and so on. So this mean time by probability of mean 5 over 16 plus and so on. So mean, so here the answer. So now we next to total of mean square time with probability of mean. So here just the complete of the answer and so on. So here the answer now we can proceed and now we have the answer we just okay. So here we have the formula. So here the answer. Thank you.
Now I would like to talk about the mean and the standard deviations of the sampling distribution. For further explanation, one example will be discussed to describe in detail. For instance, the mean and the standard deviations of the weight of all ostriches in the zoo are 115 kg and the standard deviation is 20. Suppose random sample of the site is 325 are drawn from the population of ostrich. What are the mean and the standard deviations of the sample mean X? Given that the sample size is 335, the mean is 115 kg, so the solution is 20 divided by square root of 335. The answer is 1.109.
Example 3. The CGPA of HE19 at UMS Cow has mean of 2.78 and standard deviation of 0.5. If a random sample of size 100 is taken from the populations, what is the probability that the sample mean will be between 2.68 and 2.88? The information given that the mean of the sampling distribution of X bar is equal to the mean of population from the sampling, which is 2.78. The standard deviation of the sampling distribution of X bar is equal to the sigma divided by the square root of n, which is 0.5 divided by the square root of 100. So the standard deviation of the sampling distribution of X bar is equal to 0.05. So we need to find the probability of the sample mean between 2.68 and 2.88. First, we need to convert the both number into a z-score, which is 2.68 minus the sampling distribution of sample mean 2.78 divided by the standard error 0.05. Same goes to 2.88 minus 2.78 divided by the standard error 0.05. So we will get the number of negative 2 and also 2. So we draw out the standard normal distribution. We need to find the area under the curve between negative 2 and also 2. The positive 2 will be at the right hand side and the negative 2 will be at the left hand side. So we need to find the area under the curve between these two numbers. To find out the area under the curve between negative 2 and 2, we take the 2 minus negative 2. To know the probability of 2, we look at our Z table. So the probability of 2 is equal to 0.9772. For the Z table of negative 2, the probability will be 0.228. So the probability between these two numbers is equal to 0.9544.
We back! Thanks for watching our video!